Okay, we're going to meet the chain rule. The chain rule is a way of differentiating two functions, one buried within another. So for example, we might have sine of, let's pick a fairly simple one to begin with, 2x plus 1. Okay, so we want to differentiate this. In order to do that, we're going to say, well, I don't know how to differentiate sine of 2x plus 1. However, I do know how to differentiate sine of just a different variable. Let's choose u. So what I've done is I've let u equal 2x plus 1. And we want to differentiate this. What we can say is, I know how to differentiate u with respect to x. That's easy enough. That's going to be 2. And I also know from over here how to differentiate y with respect to u. That's just going to be cos u. But remember, u is just some dummy variable that we've made up. We don't actually know what dy dx is yet. What we're going to do though is we're going to use a clever little trick. We're going to think of dy dx as a fraction. We'll see briefly in a moment why we're allowed to do this. Dy dx is not in fact a fraction, it's just notation meaning the derivative of y with respect to u. But we wanted to know dy dx. If we think of these as fractions though, and it's helpful to think of them as fractions if not entirely accurate, we can see that dy dx will equal dy du multiplied by du dx. You can kind of see those dummy variables, du's, it looks like they cancel. Okay, so du dx, that was just 2. And dy du was cos of u. But remember that u is just a dummy variable. So dy dx is actually equal to 2 cos of 2x plus 1. That seems a really long-winded rule to use. And what it essentially boils down to is you say, we just differentiate that function as per usual. So sine differentiates to cos. The function in there, that secondary function, doesn't change. It was 2x plus 1, it's still 2x plus 1. However, I have to multiply by the derivative of that inner function. Okay, so let's just see that. That's the method behind it. Let's just see how it works in practice. So let's say that we wanted to differentiate e to the x squared plus 3. Well, we know that e to the x just differentiates to itself. So we know that our derivative is at least going to be of the form e to the x squared plus 3. Always think the form of the derivative. E to the x differentiates to itself, so e to the x squared plus 3 will differentiate to something e to the x squared plus 3. But we must then multiply by the derivative of this secondary function. The derivative of that is 2x. So we've applied the chain rule in one line and reached our answer. That's how you're going to use it day to day. We've seen the logic behind it. This is how you'll actually use it in practice though. Okay, we'll just see one or two more examples of that. Let's say that we had ln of sine 2x. Just need to be a little bit careful here because we've actually got two inner functions. So we'll apply the chain rule. And I've heard chain rule described as an onion before. It's got layers and a big one makes you cry. So we'll start on the inside. The derivative of that is 2, so we know we need to multiply by the derivative of that. Then we'll look at the next function up. The derivative of sine x is cos x. we know we'll need to multiply by the derivative of that, remembering that we actually had 2x rather than just x. And then we differentiate ln. Ln just differentiates to 1 over that inner function. Cool. We've got the derivative, just apply the chain, one chain at a time, and we can tidy this answer up. Remembering that as we've got cos over sine, we've got the reciprocal of tan, which we write as cot. We'll just do one more like that. So this one's a chain rule, but doesn't necessarily look like it at first. Let's differentiate sec to the, don't know what order you're watching the videos in, maybe you haven't seen how to differentiate sec yet. Let's differentiate sine to the 4x. Okay, so differentiating sine to the 4x doesn't initially look like a chain rule. However, if I see it as sine of x to the power 4, now it looks like a function within a function. The inner function is sine x, the outer function is to the power 4. So again, start on the inside, differentiate sine x, that goes to cos x. And then I know how to differentiate to the power 4. I times by the power and reduce the power by 1. Just writing that in a slightly tidier way. Anytime you're differentiating sine or cos or sec or tan or any kind of trigonometry to a power, you can do it via the chain rule. And that's probably all you need to know about the chain rule.